Hello and welcome to today's PIR live event brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. If you don't have a calculator or dice with you already, you may wish to grab some so you can work along with us during the presentation. If that's not possible, don't worry, you're still in a good place today. They just might be a little bit handy if you have them around. If you are joining us live, remember that you can ask questions anytime throughout the webinar, and we'll make sure to queue them up for the proper time during our Q&A section. You can do so by clicking chat in the top left corner of your screen, making sure to change the to field in your chat window so that it includes attendees or everyone, depending on your version of the software. And I will relay those questions to our guest, or at least as many of them as I can get to when it's time. If you include your name, school, or city, we'll be sure to give you a shout out when we ask your question. So today's guest is Dr. Lynda Colgan. She is a professor of elementary mathematics and director of the Community Outreach Center at Queen's University. She's also the 2014 recipient of the Partners in Research Mathematics Ambassador Award. So welcome. Thank you so much for joining us today, Dr. Colgan. I will let you take it away.
This is a real privilege and honor. I will get my screen showing right now. Okay, there we go. Basically, what I would like to do this morning is talk about how when we use math, we can sometimes get some magical experiences. And I'm just going to wear my magic hat for a little while because I think that will help us as we go through. Today, I'd like to do 4 tricks with you. And the first is going to be to guess your secret number. I know that I won't be able to hear you, but I'm hoping that you will be doing the shout outs when I ask you to. I am also, even though I'm sitting in my office here in Kingston, Ontario, I am going to be able to guess everybody's age by simply doing a small trick. I'm going to have another secret number trick, and then I'm going to prove to you that as a mathematician, I can see right through a stack of dice. So let's get started right away. If you have a piece of scrap paper and a pencil, that would probably help you as we go through this. All right, here we go. I am getting ready to predict a secret number. This is what I'd like you to do. On a piece of paper, I would like you to pick your favorite number between 1 and 8, and don't show it to anybody else that's sitting around you. Write that number down. Now, I'd like you to multiply that number by 3. Has everyone done that by now? I hope so. Next, I'd like you to add 3. Next, I'd like you to multiply by 3. Now, I can see with my mathematical powers that everybody has a 2-digit number in front of them right now. There's 1 number in the tens place and 1 number in the ones place. I would like you to add the digits together. And on the count of 3, and this includes you too, Stacy, on the count of 3, I'd like you to shout out your number. Stacy, what's your number?
9.
There we go. Does everybody have 9? We should have. All right, let's move on to the next trick. Here's one that involves a few numbers that are a little bigger than the last trick, but I promise it's going to be a lot of fun. I'm just going to put in a little bit of a reminder. If you are using a calculator, please be sure to always press the equals sign after every line that you do. That will ensure that you get the right answer. So here we go. I'd like you this time to pick a number between 2 and 9. And again, I don't want you to show it to anybody. Make sure it's a secret. Now I'd like you to multiply that number by 2. I'd like you to add 5. Now, here is a bigger number. I'd like you to multiply by 50. Now remember, I'm assuming that everybody in the class has picked different numbers between 2 and 9, and you're going to be amazed what I can do with that information. Now, here's an important piece of information. If you have already had your birthday this year, I would like you to add 1,767. So that's where this one involves some bigger numbers and a calculator can help. If you haven't had your birthday this year, I'd like you to add 1,766. Now, I would like you to subtract the 4-digit year that you were born. So if you were born in 2009, you would subtract 2009. If you were born at another year, you just plug in the year you were born. And remember that you need to press equals every single time. Now, whoops, I'm going to go back. Everybody should have a 3-digit number on your screen. Stacy, do you have a 3-digit number on your calculator screen?
I do indeed. And part of that number looks familiar.
And the first number should be the secret number that you picked at the beginning.
It is indeed.
And the last 2 digits should be your age.
They are indeed.
My magic trick worked. I hope it's working in all of these classrooms across the country. The first number will be the secret number, and the second 2 numbers will be your age. And for some people, if you're only 8 years old, it could be 08, but that's just fine. It's still your age. Wasn't that fun? Okay, let's move on to our next trick. Stacy, I'm going to need your help here for this one because I don't have an opportunity to have an audience. And usually when I do magic tricks, my audience shouts things out to me. So Stacy, I would like you to pick a number between 1 and 63, but don't tell me.
Okay.
Write it down, Stacy.
All right.
Now, Stacy, on the screen, you will see 6 magic cards. Do you see 6 magic cards?
I do.
Stacy, is your secret number on card number 1?
No.
Stacy, is your secret number on card number 2?
No, it is not.
Is your secret number on card number 3?
No.
Is your secret number on card number 4?
No.
Is your secret number on card number 5?
Nope.
Is your secret number on card number 6?
Yes, it is.
I believe, all the way from Kingston, Ontario, Stacy, that your secret number is 32. Am I right?
No, you are not
Yes!
correct.
Yeah, no? Then
No.
Stacy, I want you to look at those cards again. Is your number?
I bet I made a mistake. I looked and I saw it on one card and I assumed it was only on that card.
Yes, it could be on other cards. So let's try again,
Okay.
Stacy.
Okay, let me
Because
have a
my
look.
mathematical powers never fail me.
Okay.
Stacy, is your number on card number 1?
No.
Is it on card number 2?
No. See, now I'm double checking. I'm being very careful.
Be very careful. Is it on card number 3?
Yes.
Okay, this is good. Is it on card number 4?
No.
Is it on card number 5?
Yes.
Is it on card number 6?
Yes.
This time, I'm sure I have the correct number. Stacy, is it 37?
It is 37.
There we go. I knew my magic powers wouldn't fail me.
Oh, your assistant just failed you this time.
There we go. Now, we're going to go on to the last trick, which I'm going to call roll 'em, roll 'em, roll 'em. About all of these are about dice questions. So, this is what I would like people in the audience to do. I would like you to have one die in front of you. Stacy, do you have a die in front of you?
I do not, unfortunately.
But can you picture a die in your head, Stacy?
I can do that.
Okay. So Stacy, what number would you like to have on top of your die?
How about number 6?
Okay. So if Stacy has number 6 on top, I can predict that on the opposite side of the die, even if I keep my eyes closed, I'm going to see number 1. If I take 2 die and stack them up, one on top of the other, Stacy, how many sides of the die can I not see? So I could 3 sides, because I can't see this side, I can't see this side, and I can't see the bottom if I'm holding it. So Stacy, I'm going to take a quick look at the top of this die. Number 1. And Stacy, I'm going to predict that the sum of the other 3 faces on the die is equal to 13. Do you believe I can do that? Okay, here we go, Stacy. You're going to do the addition for me.
Okay. So 6 plus 4 is 10. Plus 3 is 13.
I saw right through all those dice, and I knew exactly what the sum of all the invisible sides was. Now, I don't have another big die, but I'm going to use 3 small die. Just hang on one second. I've got 3 small die. And I am going to make another tower out of my die. All right? Do you agree that that is a tower? I've got to get my camera in the right place. Hold them up like this.
Okay, I see a tower of 3 dice.
I have a tower of 3 dice. So Stacy, this time, how many sides can I not see?
You cannot see 5 sides if you put it on top of your hand or a table.
Right. So Stacy, I'm going to show you what's on top, I think.
A 2.
Okay. So Stacy, I know for a fact that the sum of the 5 sides is equal to 19, and we're going to prove it together. So you're going to do the addition.
Okay.
Stacy.
So 5 plus, other way.
Other way. Woo, woo,
A
woo.
mirror plus 6. So 5 plus 6 is 11. Plus 11 plus 1 is 12. 12 plus 5 is 17. And 17 plus 2 is 19.
It's magic. I can see through the dice.
I think I need your hat. Is it the hat?
It's the hat. The hat is exactly what makes the magic work. So Stacey, we're going to try one more. This time I've got 4 dice in a tower. Can you see them?
I can see them.
Okay, Stacey, how many sides can you not see? How many faces can you not see?
7 if they were sitting on a table.
Right, if they were sitting on a table, there are 7 faces that you cannot see. So Stacey, I am going to, oops, I just dropped my last little die. Stacey, I'm going to show you what's on the top.
Is it a 3?
It's a 3.
Okay.
So Stacey, I am going to prove to you, I am going to predict that the 7 faces that I cannot see will sum to, oh, let me see, I think 25. Okay, so Stacey, here's your job to add these numbers.
Okay, I see a 4. And 4 plus another 4. I've got a bit of glare there.
Yeah.
Okay, 4 plus 4 is 8.
And now?
A 3, so 8 plus 3 is 11. 11 plus 2 is 13. And that one's just out of the frame for me.
Oh, sorry.
And what were we at? We were at 11 plus
We're at 13.
13. Sorry, 13 plus 5 is 18. 18 plus 2 is 20. And 20 plus 5 is 25.
There we go. My prediction was correct. Stacey, I could take any number of dice, stack them as high as you could imagine, and I would be always able to predict the sum of the sides that you can't see. And that is Mathemagic. So now I'm going to turn it over to some questions. Okay, thank you for being my wonderful magician's assistant today, Stacey.
Only one mistake.
Only one.
Okay, well, I have to ask the obvious question. Is Mathemagic actually magic, or is there some type of figuring out or some rules that you're able to follow?
Well, I'll start with the last trick first. The last trick that involves the die, this is how I do it. Now, usually magicians don't tell their secrets, but I think it's important for us to share them in math. One of the things that everybody should know is that the opposite faces on a die always sum to 7. So if you have 3 on one side, you're guaranteed to have 4 on the other side. If you have 1 on this face, the opposite face will be 6. If you've got a 4, you're going to have a 3. If you've got a 2, let me find my 2 here. Where's my 2? You will have what on the other face, Stacey?
A 5.
A 5. So if I know that the sum of the faces is always 7, if I have a stack of 2 die, I know that the sum of the faces has to be 2 times 7 or 14. So all I do is look at the number on the top and I subtract that from 14. If I have a stack of 3 die, that's 21. And I just peek at the top one and subtract that from 21. If I have 4 dice, it's 28. If it's 5 dice, 5 times 7 would be 35. And all I need to do is take a quick peek at the top number And then I can automatically know the sum of all of the other faces on the die, just by knowing that one rule. Now with the other rule, with the other questions, I'm going to go back to the slide where I asked you about checking your number. For example, Stacy, your number was 37. How did I figure that out? Stacy, you told me that your number was on card number 3. So what I did was make a mental note of the number in the top left corner of that slide, which was number 4. Then you told me that your secret number was on card number 5. I looked at the top left-hand number there, saw that it was a 1, and I added 4 and 1 together to get 5. Then you told me that your number was on card number 6, and I added that to the number in the top left corner to get 37. So, for example, we're going to do, Stacy, I'd like you to pick another secret number, and don't tell me again.
Okay. Okay.
Between 1 and 63.
Yes.
Okay. Is your number on card number 1?
No.
Is it on card number 2?
Yes.
Is it on card number 3?
Yes.
Is it on card number 4?
No.
Is it on card number 5?
Yes.
Is it on card number 6?
No.
Stacy, I predict your number is 13.
Well, let's see. My number's written down, so I didn't forget it.
13. Now, the reason I was able to predict your number is that you told me your number was on card number 2. So I looked at the top left corner, and there's an 8 there. Then you told me that your secret number was on card number 3. So I looked at the top left number, which is number 4. And then you told me it was on card number 5. So I add all the numbers in the top left corner together, 8, 4, and 1, and that gives me 13. So basically, for any number between 1 and 63, if I look at the top left corners and add them together, I can guess the secret numbers. And that's because these are called binary numbers. They're a special kind of number. Now, the other 2 tricks about guessing secret numbers are actually based on algebra. And I will, again, be able to do any question that involves a prediction by always remembering that in math, what I add to one side, I have to do the same to the other. So it's all about keeping things balanced.
Sounds good. Well, I have a few more questions now.
Good.
I'm madly transcribing from our audience. Keep them coming. That's wonderful. We have a question from, let's go to AC in Port Hope, wondering how you knew her age.
Well, I'm going to go back there. And basically, this trick, again, we pick a number between 2 and 9. And in what I do in algebra is I just call that a square. And when I multiply it by 2, I now have 2 squares. I add 5, so that means I add 5 beans to it, and then I multiply by 50. What I've done is basically figure out that no matter what way, how those numbers, no matter what secret number you predict or use at the beginning, if we add the 1,767 and the 1,766, we end up with a large 4-digit number. And by subtracting the year you were born, and again, I'm using these numbers because I'm guessing around the age or the years in which people were born. When we subtract them, no matter what you start with, no matter what year, no matter what, whether you had your birthday or not, everybody gets a 3-digit number. And the first number is always the secret number, and the last 2 digits are always the age. And this will work for anybody. Now, I will tell you something special about this trick. If you want to use this trick next year in 2018, then you have to change the numbers to 1,768 and 1,767. So those are the numbers that are magic in terms of helping me to decide how to predict your age. Hope that helps.
Very interesting. Well, we definitely had some, I'm getting some feedback from you. And we had some questions for sure from students asking how they could replicate this, I think, for their friends. So I think that was the one that they needed that slide up again. So that's wonderful. We also have a question from Ava at Rolfe Road, wanting to know how long it took you to come up with the magic tricks.
Ava, one of the things that I'm going to say is that I had a wonderful teacher when I was in school, and his name was Mr. Saramaki, Mr. Peter Saramaki. And every day, Mr. Saramaki would come into class and he would start out by having some fun activity with us. And I started to think about ways that I could make math fun for people. And so I started trying to learn from other mathematicians. I tried to learn some of their tricks, and then I tried to make up some of my own. Some of the tricks take maybe half an hour. Some of the tricks maybe take a whole afternoon. But I love playing with numbers, and I love trying to trick people and make them smile. So whenever I have an opportunity to do a magic trick and get people to figure it out, I just love that. I've just had a trick come to me recently where I can guess people's phone numbers, and I have to tell you, they just love that trick. So maybe next time we'll do that one as well. Lovely question. Thank you, Ava.
Okay. So next we have a question from Jack at Allenby, who wants to know, what was your favorite strand or subject in math at school?
I have to say that my favorite subject was always geometry. I love geometry because it has application to nature, and it has application to art, and it has application to music. And so as a hobby, Jack, I like to make tessellating patterns, and I like to make different kinds of tiles using tessellations. I like to teach people how they can use mathematics to draw figures, and how they can use mathematics to improve their photography. But when it comes down to simple things that I can do with my family at the kitchen table to bring a smile, it's usually a number trick, Jack. Those are the ones that work quickly and give me a lot of pleasure. So thank you for asking.
Excellent. Well, we are at 11:30 already. For those who can stay with us, I'm going to answer a few more questions, but I likely can't answer any new questions that are being sent in now. So we will try to get to a couple more before we end for today. The first one of those would be from Midnapore School, asking, how you became a mathematician.
I have to say that when I was in elementary school, I really enjoyed math, but I didn't really always understand how it could apply to the real world or how it could apply to my life. But I was very, very lucky from the standpoint that my father used to do things. So as we were walking along the street, we would sometimes practice multiplication tables. And then he would point things out, like the patterns in driveways, and he would have me look at them and think about how the patterns all fit together. He asked me questions about simple things like leaves and the symmetry of leaves. And I found that just by having someone, in my case it was my father, but in other cases I know people had a teacher who did this, just by having someone make me a little bit more curious, I began to do projects on my own to find out ways that I could see how math was used. And so I investigated a lot of different things. So, for example, I could have done a trick where I predicted that everybody in the audience was 7 feet tall. And did you know that everybody is 7 of their own feet tall? If you were to trace out your foot and make 7 of them, and then lie down beside those 7 cutouts, you would find that you are 7 feet tall. The other thing that you would find is that your foot is exactly the same length as the distance between your wrist and your elbow. And if we had one of those paper feet, we could actually wrap it around our fist. So if you ever want to know if a pair of shoes is going to fit, you just put it on your forearm. And if the shoe is the same length as your forearm, it will fit your foot. And if you want to know if a pair of socks will fit, you wrap them around your fist because that's exactly the same length as your foot. So there you go. Everybody is 7 feet tall.
There, a little bonus anatomy for us today.
Yeah.
Okay, so I am going to try to squeeze in, I think 3, maybe 2 more questions are already over. So we do have a few questions coming from Mrs. Brothers' class and a few others wanting to know how the first trick was done.
Okay, let me go back to the first trick. All right. So when you pick a number between 1 and 8, and then you follow all those steps, multiply by 3, add 3, multiply by 3, you get a 2-digit number. Now, what I have done is ensure that basically everybody's 2-digit number is a multiple of 9. So no matter what number you begin with, you're going to end up with 18, 27, 36, some variation of a multiple of 9. And one of the rules, 9 is a very special number. Basically, when you have a multiple of 9, the 2 digits that make up that multiple sum to 9.
There we go. We just had a little audio glitch there.
Okay, so the 2 numbers always sum to 9. So 9 is a magic number from the standpoint of its multiples have that property. Always, always, always. So if you think of 9 times 9 is 81, 8 plus 1 is 9. 9 times 8 is 72. 7 plus 2 is 9. As we go through all of those numbers, the multiples of 9, you will always get a 2-digit number, and it will always have those 2 digits sum to 9.
Excellent. And my very last question here that I'm going to squeak in is a question from Layla at Midnapore asking, when you were in grade 5 or 6, were you good in math, or did you get better and learn your tricks along the way? And we had several other students who were asking similar questions as well.
Layla, I have to tell you that in grade 5, I had a wonderful teacher named Pat Harvey, Mrs. Pat Harvey, and she was very inspirational. But Mrs. Harvey was one of those teachers who always taught us how valuable it was to learn from our mistakes and to go back and find the error and to do our work. So, Layla, I have to tell you that I was not a mathematician in grade 5 by any stretch of the imagination. I have practiced and learned from other people and on my own over time, and I hope that I always continue to learn new tricks and to learn from people and never stop inventing new problems. Thank you for that question, Layla.
Excellent. And if you want to go ahead, now that we've talked about all the tricks, we can stop sharing those slides, I think, as we finish up here. That is all the time we have. Dr. Colgan, thank you so much for joining us and showing us a little bit of fun today with math. I think there's a misconception about math always needing to be difficult and strict and serious, and it's nice to see the lighter side and the neat parts to math. Before we do sign off, do you have anything else you'd like to tell our students today? Maybe a little nugget of wisdom or advice for those who may be thinking about pursuing some Mathemagic?
I have a little poem. Always remember and never forget, mathematics is magic. On that you can bet.
Very cute. Well, thank you so much for your time today.
Thank you. It was a real pleasure and an honor to be here.
And next week on PIR Live Event, we'll learn about dark matter with an expert joining us from 2 kilometers underground at Snow Lab in Sudbury. And we also have other events posted on our webinar schedule through November, and you'll see more and more added as we go. So you can find out more information about upcoming webinars and other educational programming at pirweb.org. Thanks so much for joining us today and working a little on your Mathemagic. We will see you next time. Goodbye, everybody.